Hello kids, let's move ahead in this chapter and I hope that you have done your homework. So what we have next here is 7.4 marking fraction lengths on the number line. So what we have given here is a number line and different numbers are marked on it. So till now we have learned that how we have to mark the integers on the number line, and in this chapter we are going to see that how we have to mark the fractions now. Okay, so here we have marked length or equal to 1, 2 and 3 units on the number line. Now let us try to mark length equal to fractions on the number line. What is the length of the blue line? Write the fraction that gives the length of the blue line in the box. So kids, if you see here, this is the number line where we have 0, then this mark is there, 1, another mark, and then 2. And if you notice here that all these marks, this one, this, all the marks given here, they are at equal distance with each other. And we can see that this particular mark between 0 and 1, it is midway between these two. So that means this is half, this is 1 by 2, this is the half distance, this is representing the 1 by 2 of the complete 1 unit here. So we have 0, 1 by 2, and we can also write 1 by 2 in decimals as 0.5. Okay, so if you see your scales, if we see the scales which we use in mathematics, all these numbers are marked in decimals also in few of the scales. So after 0, we have 1 by 2, which is in half of the distance. Then after 1 by 2, we have 1. So the distance between these two is also half here, right? And then after 1, we have another mark here which we have to fill. This will be 1, 1 by 2. Okay, 1 and half. Or you can also write this as 3 by 2. And the last one is 2. Okay, so I hope you have understood what we have done. All the marks, they are at equal distances with each other, and the marks which are given to us are 0, 1 and 2, and the other marks which are in midways are half, which we can write as 1 by 2, and then 1 and half, which we can write as 3 by 2. Okay, so this is how we can write it. Similar to this, we are given with the another number line where the division is like this. So if we see here between 0 and 1, we have 2 marks now, in a way that this distance, and this distance, they are equal. So this whole one from 0 to 1, if you see only from 0 to 1, we have first mark here. So this distance is there, another mark is there, this distance, and the third mark is there. So we can say that this 1 unit is equally divided into 3 parts, right? So the length of each part will be 1 by 3. This distance is 1 by 3. So this mark will be after 1 by third of the distance. Another will be, this distance will be 2 by 3. Okay, and then 1. And kids always understand this, that we can represent this one as 3 by 3 also. So if we have to write this in the form of fraction, we can also write this as 1 by 3, 2 by 3 and 3 by 3. And 3 by 3 is nothing but, if we divide, this will be 1 only. Okay, so we have to write 2 by 3 here. And this is 1, or you can write 3 by 3. After this, we will have 4 by 3. This distance will be 4 by 3 here. Okay, so these are the marks which we can show. There will also be another mark here which they have not drawn. So this will be somewhere around here, and we can represent it by 5 by 3. And then 2. And again 2. Again 2 is what? It is 6 by 3. If you divide it, you will get 2. Right? So this is how we can mark the fractions on the number line, right? Between 0 and 1, there were 2 marks which was dividing it into 3 parts. 3 parts means we can write this in the form of fraction as 1 by 3, 2 by 3 and 3 by 3, or 1 as the distance. Each has the length of 1 by 3 only, right? This is similar to what we have done in the previous exercise. Only difference is here we are representing that thing on the number line, right? Now, next we have here a unit, that is a 1 is divided in 5 equal parts. So now in this question, instead of 3 parts like what we have just done, we are dividing this unit length into 5 equal parts. And then we have to write the fraction that gives the length of the blue lines in the respective boxes. Okay, so easy. Between 0 and 1, we have 1, 2, 3, 4. So that means these are 1, 2, 3, 4, and 5. 5 equal parts. We are dividing 1 into 5 equal parts. So that means each part will be of 1 by 5 length, right? So from 0 to 1 by 5, it is 1 by 5. 0 to here, it will be 2 by 5, right? 0 to here will be 3 by 5. 0 to here will be 4 by 5, right? Let us also write this. This will be 5 by 5. That's why it is 1, right? Because it will something be like 5 by 5. If you divide, you will get 1. Next, 6 by 5, 7 by 5, 8 by 5, 9 by 5, and this is 2, which can also be written as 10 by 5, because if you simplify, this will become 2. Okay, so this is how we have to draw the fractions on the number line. Now a unit is divided into 8 equal parts. Write the appropriate fractions in your notebook. So now what we are doing, we have a unit that is from 0 to 1. Sorry. Okay, this is being divided into 8 equal parts, means we have to divide, mark 7 separators, 1, 2, 3, 4, 5, 6, 7. Okay, this is 1 and this is 0, starting point. So if you see here, this is one part, second part, third, fourth, fifth, sixth, seventh, and eighth. That means we are dividing every part into 8. Every mark represent 8 equal parts. We have divided one unit into 8 equal parts here. So the length of each unit will be 1 by 8. Yes, we understand that. We have done this. Now, when we have to mark the points, those will be marked always with respect to 0. So from 0 to this, it will be 1 by 8. From 0 to this point, 2 by 8. 0 to this point, 3 by 8. 0 to this point, 4 by 8. 5 by 8. 6 by 8. 7 by 8 and 1, or you can also write this as 8 by 8, which means 1 only. Okay, so this is how we have to represent it on the number line, right? Now let's move further. In the figure out, we have on a number line, draw the lines of length 1 by 10, 3 by 10 and 4 by 5. So that means we have a unit and we are dividing that into 10 equal parts, right? So let us make another, I am writing here question number 1 and I am making another line here from 0 to 1, where we should have 10 equal parts. So 10 parts means 9 separators. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we have to always make them equidistant. Whenever you use a scale, always make at equal distances. Okay. So 0 to 1 we have marked. Now what we have to do, we have to mark the length of 1 by 10. So since we are dividing into 10 parts, each of the parts will be equal. So the first will be 1 by 10, then 2 by 10, 3 by 10. Let me mark all first. 4 by 10, 5 by 10, 6 by 10, 7 by 10, 8 by 10, 9 by 10 and 10 by 10, which is also 1, which we have already written here, right? Now what we are supposed to mark is 1 by 10, which we have done. 3 by 10, this is 3 by 10. all the distances, this 1 by 10, 2 by 10, 3 by 10, they are with respect to 0. Like that means we are starting measuring from here, okay? And the third one, if you see, this is 4 by 5. So here we have 4 by 5. Let us convert it into the fraction where denominator is 10. Okay. So we have learned this in our previous grade. How we have to do? We have to multiply both the numerator and the denominator with the same number so that we get this 10 here. Okay. So if I need 10 in the denominator, I have to multiply 5 with 2. And if I am multiplying the denominator by 2, I have to multiply the numerator also with 2, right? So we have 5 into 2, 10 here, 4 into 2, 8 here. So that means we are expected to draw 8 by 10, which is here, and we have already marked. This is with respect to the distance from 0. Okay, easy. See kids, I am again telling you what we have done here. We want to make 10 in the denominator. So for that, we have to multiply 5 with 2, which we are doing. But again, we have to multiply the numerator also with 2, right? We have to multiply both the numerator and denominator with the same number. So we will get 8 by 10, and here we have already marked 8 by 10. Right? So this is how we have to do this question. Next, write 5 more fractions of your choice and mark them on the number line. So this is a homework where you have to pick. You can take any length. You can take 7, you can take 9, you can take 3, and accordingly, this has to be done. How many fractions lie between 0 and 1? Think, discuss with your classmates and write the answer. So this question 3 is in continuation with question 2. After doing, you have to discuss with your classmates. Okay. So this is again homework for you. You can do and discuss it in the class. Now, let's come to question number 4 here. And let me move it little down. Yeah. What is the length of the blue line and black line shown below? The distance between 0 and 1 is 1 unit long and it is divided into 2 equal parts. Okay. The length of each part is 1 by 2. So the blue line is 1 by 2 units long. Now, write the fraction that give the length of the black line in the box. So this is easy. This completed from 0 to 1 is 1 unit, and they are telling that they have marked 1 by 2 in the mid such that this length is 1 by 2 and this length is also 1 by 2, right? Again, we can see this mark is also between 1 and 2. That means this distance is also 1 by 2 and this is also 1 by 2. So that means from 0 to 2, they are marked at equal distances with a length of 1 by 2. Okay, we have made the marks. Now, the blue line is representing 1 by 2. We have to find the black line distance from 0. This is 1 by 2. This is 2 by 2, and that's why this is 1, right? Then this will be 3 by 2. Okay, and if we also want to see what is this is 4 by 2, which we are representing as 2 on simplification. Okay, so this is 3 by 2. This is also easy. Next one is also very easy, kids. This should be a homework for you, but again I am doing this right away. Write the fraction that give the length of the black lines in the respective boxes. So if you see here, we have the length given from 0 to 2, and we have the markings done here such that the distance from 0 of the first marking is 1 by 5, second is 2 by 5, and so on. So that means every marking is at 1 by 5 distance from each other. That means that distance between these two is 1 by 5, 1 by 5, and so on. Right? Now what we have to do? We have to write the length in the boxes. So we have 1 by 5, 2 by 5, 3 by 5, 4 by 5, and 1. 1 is nothing but 5 and 5. 5 by 5, right? We can write this as 1. Then 6 by 5, 7 by 5, 8 by 5, 9 by 5, and 2. 2 is nothing but 10 by 5. Simple. So this is how we have to do this question. Question number 5. So kids, now you understand that how we have to do the mark the fractions on the number line. Next, let's go to the mixed fractions. So mixed fractions, kids, we have already done in grade 5. I'm just telling you one example of mixed fraction. Mixed fraction has two parts. First, it has a whole number and then it has a fraction also. So if I write down 3, 1 by 2, here 3 represent one whole and 1 by 2 represent the fraction. Okay, so since it contains both a whole number and a fraction, it is called as a mixed fraction, right? Now let's go to this fractions greater than 1. Yes, that's true. All the mixed fractions, they are greater than 1, right? So you marked some fractions on the number line earlier. Did you notice that the length of all the blue lines were less than 1 and the length of all the black lines were more than 1 for the cases where we were measuring the length more than 1? It was true. Now write down all the fractions you marked on the number line earlier and let us classify them in two groups: length less than 1 unit, length more than 1 unit. So to do this question, let's pick up the last one only. This example, length less than 1 unit were 1 by 5, 2 by 5, 3 by 5 and 4 by 5, less than 1 unit, and 5 by 5 was 1 only, so I'm not mentioning it here. We have to write less than 1. Now length more than 1 is 6 by 5, 7 by 5, 8 by 5 and 9 by 5. So if we see this example, these are the length given to us. Now, did you notice that something common between the fractions that are greater than 1? In all the fractions that are less than 1, the numerator is smaller, but in the other one, the numerator is bigger than the denominator. So yes, we have seen this and we have also done this before. We know that in the case of the mixed fractions, the numerator is greater than the denominator. The numerator is greater than the denominator in the case of the mixed fractions. Now, we know that 3 by 2, 5 by 2 and 7 by 2 are greater than 1. But can we see how many whole units that they contain? So now what they are saying, that how we can represent 3 by 2 to understand that how many wholes are there. So kids, here we have two methods. First method is 3 by 2. Let's take example of 3 by 2. So we can write this as 3 times 1 by 2, right? We can write this as 3 times 1 by 2. That means 1 by 2 plus 1 by 2 plus 1 by 2. This is one thing we can write. And again, we know half plus half will give us 1 and this half will be remaining. So we will write this as is. This is the mixed fraction where we have one whole and one half. Easy. This is first method. I am mentioning this as method 1. We have method 2 also, which we have done in grade 5. Okay, what was that? We will simply divide 3 with 2. So we have 2 into 1 will give us 1 here. So this number should be written as a whole number and then we have to write the remainder and the divisor. Okay, so you can write this as Q, R and D. Okay, divisor. I'm writing divisor. Don't confuse with the dividend, divisor. This is another method. We can simply divide and write. Okay, so you can pick any method which you find is easy. Similarly, we can find in the case of 5 by 2 also. Okay, so let's do 5 by 2 here. We will again do with both the methods. Okay, and you can pick any method which you find easy. Both are correct. 5 by 2. We can represent 5 by 2 as 5 times half. That means we have to write 1 by 2 5 times first. Okay? Right? So we have written 1 by 2 5 times and now we have to find the number of wholes. So that is 1 half. These two half together will make 1 plus these two half together will make another one plus this half is left alone as is. So we can say we have 2 wholes and 1 half here. Okay, 2 wholes and 1 half fraction. Now method 2, simple, divide 5 with 2. We will get 2 into 2. You will get 4 here and 1. So QR by D, which means Q is the quotient, R is remainder, this as divisor, 2, 1 by 2. So we can also represent it like this. Now coming to the figure it out. How many whole units are in 7 by 2? Easy. Kids, this is homework for you. This is very, very easy. We can do by using any method. Okay. Next, how many whole units are there in 4 by 3 and in 7 by 3? So, question number 2, one part I'll do for you. I'll pick 4 by 3 here. 4 by 3 can be written as 4 times 1 by 3, right? So, we can write 1 by 3 plus 1 by 3 plus 1 by 3 plus 1 by 3. 4 times we have written 1 by 3. Now, if we combine these 3, we will get 3 by 3. That means 1. Okay. So this is 1 by 3 plus 1 by 3 plus 1 by 3. 3 times will give us 1. So we will have 1 here and remaining is this 1 by 3. So this is the answer. 1 by 3. Second method, method 2. How we are going to do? Just divide. 4 and 3 into 1 is 1. So Q R by D, that means quotient, remainder and divisor. This is the answer. Okay. So similarly, you can do it for 7 by 3. This 7 by 3 is a homework for you. Now let's move further. We have figured it out here. Figure out the number of whole units in each of the following fractions. 8 by 3, 11 by 5 and 9 by 4. We saw that 8 by 3 is equal to 2 by 3, where this is a mixed number, this is a fraction. This number thus is called 2 and 2/3. Okay. We can also write it as 2 by 3. That's correct. We have already done this. So similarly, we have to do it for B and C. So let's pick question number 1, B part, 11 by 5. I'm picking method 2, kids. So we have 11 and 5. 5 into 2 is 10 and 1 is remaining. So this is Q R by D. Okay. This is the fraction and we can write it as 2 and 1/5. Okay. 2 and 1/5 as the answer. Similarly, this is already done here. This we have done and this one is something you have to pick. Okay. Now, can all fractions greater than 1 be written as such mixed numbers? So, a mixed number or mixed fraction contain a whole number and a fractional part. Yes, we can write down all the fractions greater than 1 in the form of a mixed number. Okay. Now, write the following fraction as mixed fractions. We have to write them as mixed fractions. Question number 3. Wait. Question number 3. I am picking the 9 by 2 is already done. So, I am picking 9 by 5 here. Okay. Or let me pick C part. C part is 21 by 9. So, what we will do? Simply divide. 19 into 1. Here we will get 2. So, this is, what is the formula? Q R by D. Q is quotient, R is remainder and then 19 is the divisor. Okay, this is our mixed fraction, how we have to write it. Similarly, I'm doing F also, 19 by 6. Okay, so 19 by 6 we'll have to divide 19 and 6. 6 into 3 is 18. This will give us 1. So, quotient is 3, R 1 and D is 6. So, this is the fraction. Okay. So, this is how we have to do we have to write the mixed fractions. You can use any of the method, and this is very easy to do. Okay, so next what we have are the equivalent fractions. So kids, we have done equivalent fractions in the previous grade, where we know that equivalent fractions are the fractions which have same value but they look different. Okay, and same I have written here, the fraction that represent the same value but they look different. They have different numerators or denominators. They are called equivalent fractions. Examples I am telling you here. Example of equivalent fraction is, if we say we have half, the equivalent fraction of half will be 3 by 6. It will also be 2 by 4. It will also be 4 and 4 by 8, 5 by 10, and so on. So if you see these fractions, if you simplify them, you will get the same value. 1 by 2 cannot be reduced further. This is the lowest form. So 1 by 2 is as is. If you try to simplify 3 by 6, we know how we have to simplify a fraction. Yes, we divide both the numerator and the denominator with the same number. So we have to think of a number where both the numerator and denominator, they can be divisible by that number. Okay, so in the case of 3 and 6, both of them, they are coming in the table of 3. So I can write 3 by 6 as 3 into 1 is 3, 3 into 2 is 6. So that means 3 by 6 on simplification is giving me 1 by 2 only, which is same. Coming to, I'm picking 5 by 10 here. This is 5 into 1 is 5, 5 into 2 is 10. Again, it is giving us 1 by 2. 4 by 8, if you simplify, again same. This is also same. If we have to divide by 2, here we are dividing by 4. So, these all fractions, they have same value, but they have different numerator and denominators. Okay. So, now let us come to the 7.6 equivalent fractions. In the previous section, you used paper folding to represent the various fractions using the fractional unit. Let us do some more activities here. So now what we have done here is, this was the strip of 1 unit length. Same we have taken and they have marked the half of it in blue. So this half is represented by 1 by 2 here. Moving further, we are again dividing this half into 2 equal parts. Okay, so that means this is 1 by 4 and this is 1 by 4. I am writing here. If we are dividing this, we have 1 by 4 and 1 by 4. But when we combine these two, we'll have 2 by 4. Right? So this was represented as 1 by 2 above. Now when we are again folding it, we are representing the same portion with 2 by 4. And moving further, we are again dividing this 1 by 4 into 2 equal halves, this 1 by 4 into 2 equal halves, in a way that all the portions are 1 by 8 now. These all portions are 1 by 8 now. Okay. So now these all portions are 1 by 8, but when we combine them together, this is 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8 equal to 4 by 8. So you see that the same strip of paper which is in blue can be represented by 3 different fractions. It is being represented by half above, then 2 by 4 and then 4 by 8. Okay, but when we simplify this is nothing. All the fractions have the value of 1 by 2. So here 1 by 2, 2 by 4 and 4 by 8, they are called as the equivalent fractions. Okay, they are looking different, but they have the same value on the simplification. Now, next is, now check whether 1 by 3 and 2 by 6 are equal fractions or not. So kids, this is easy. We have 1 by 3, we have 2 by 6. We know that 2 and 6, both of them, they are coming in the table of 2. So we can divide them. We have 1 by 3 only. 2 into 1 is 2, 2 into 3 is 6. Okay, so that means yes, they are equivalent fractions. We are writing yes here. Now make your own fractional wall using such strips as given in the picture below. So this is one example of a fractional wall they have made, where we can see that one unit can be represented in many different forms. Okay, if we divide this one unit into two equal halves, it is 1 by 2 and 2 by 2. Okay, and if we are dividing this one unit into three equal parts, it is 1 by 3, 2 by 3 and 3 by 3. And for 4, 1 by 4, 2 by 4, 3 by 4 and 4 by 4. Similarly for 5 and similarly for 6. So we can do this, we can make it for any number. Okay, if you see the figure which is given here, it is being extended till 10. So this is still 6 only, where we are dividing one unit into 6 equal parts. Here we are further dividing one unit into 7, then each 9 and finally 10 equal parts. So this can be done for any length. Now let us move to the question. Answer the following question after looking at the fraction wall. This is fraction wall. Are the length 1 by 2 and 3 by 6 equal? So yes, we have seen this is 1/2. Okay, and if I see 3 by 6 using the wall, then it starts from here 1 by 6, 2 by 6 and 3 by 6. This is 3 by 6, same, this is half. So using the wall, yes, they are equal. Simplifying them, yes, they are equal. So we will write yes. Then are 2 by 3 and 4 by 6 equivalent fraction? So this is 2 by 3 starting from here till here, and then we have 4 by 6. So if you see 4 by 6, this is 4 by 6. We are comparing this 2 by 3 and 4 by 6, right? The starting point is same, the end point is same. That means they are equivalent from the wall. Now let us try to simplify them. 2 by 3 cannot be reduced further. This is the lowest form. Coming to 4 by 6. We know that 4 and 6, they come in the table of 2. So we can divide both with 2 now. 2 into 2 is 4, 2 into 3 is 6. So we get the same value here. 2 by 3 and 2 by 3. So yes, they are equal. Now, let me erase this first and then we will move further. Third question is, how many pieces of 1 by 6 will make a length of 1/2? So kids, you see here, this 1 by 6 plus this 1 by 6 and this 1 by 6 is making half. That means 1 part, 2 part and 3 part. Or I can write 3 parts of 1 by 6 makes 1 by 2 length. Okay, makes a length of 1 by 2. And if you also simplify it, it is something like 3 into 1 by 6. 3 into 1 is 3, this is 2, which will give us half only. Okay, so with the fraction wall and without the fraction wall also, you can always simplify it. This answer will be 3. Next, how many pieces of length 1 by 6 will make a length of 1 by 3? So kids, this is very easy. We can see here 1 by 6 and 1 by 6. So 2 pieces of this will make the length of 1 by 3 here, right? So question number 4, 2 pieces of 1 by 6 will make 1 by 3 using the wall. Otherwise also, we have to see how many pieces of 1 by 6 will make 1 by 3 here. That means we have to make 3 here. So what we are going to do? We have to divide this in a way so that we get 3 here. So what we have to do here is we are going to multiply this with 2. So we'll get 2 into 1 and 2 into 3. Simple mathematics. So this will be 2 here. Answer is 2. Okay. Similarly, we have given the fractional wall till 10 here. Okay. And now let's do this question very quickly. Are 3 by 6, 4 by 8, 5 by 10 equivalent fractions? Why? So question number 1, I am writing here. 3 by 6, 4 by 8, 5 by 10. Let's simplify them. Okay, let us reduce them to their lowest form first. So 3 by 6 is equal to, If I divide 3 into 1 is 3, 3 into 2 is 6. We can write this as 1 by 2. Also, 4 by 8 is equal to 4 into 1, 4 into 2, half. Then the last one, 5 by 10. Same, 5 into 1, 5 into 2, which will again give us half. So, if we simplify these fractions, we will get the same number. We will get the same length, that is half. So, that means they are equivalent fraction. They look different, but they have the same value, and that is 1 by 2. So, yes. Why? Because they have same value. They have same value of 1 by 2, which we have just taken out. Now, write two equivalent fraction of 2 by 6. Question 2. Very easy. We have done many questions like this in grade 5, right? So, equivalent fraction for 2 by 6. So what is the method, kids? The method is, first of all, we can, first thing, we have 2 by 6 and let us reduce to its lowest form. So when we reduce it to its lowest form, it will become 1 by 3, right? Now let's try to find out the equivalent fractions of 1 by 3. How we have to do? We have to multiply both the numerator and denominator with the same number, right? If I multiply this with 2, I will get the same 2 by 6. If I multiply this with 3, then we'll have 3 by 9. Then multiply both the numerator and denominator with the same number, we will get 4 by 12. Okay? And if you don't want to reduce it, that's also fine. You can also start simply from here. We have 2 by 6. We want to find the equivalent fractions. We can multiply both the numerator and denominator with the same number. So we can write 2 by 6 into 2 into 2. That means 4 by 12, which we are anyways getting here. Then 2 by 6 into 3 into 3. 6 and 18. 2 by 6 into 4 into 4. 8 and 24. So all these fractions, they are equivalent fractions. If you simplify, you will get 1 by 3 in every case. Okay? So I hope that you have understood this. This is done now. Next, what we have here is 4 by 6 is equal to, so here also we have to write the equivalent fractions, and yes, this is the homework for you. I'm writing this as a homework. Okay, so kids, this equivalent fractions, we have more exercises on this, more examples, which we are going to cover in the next class now. You please go through these all questions, practice them at home and do the homework also. And if you have any queries, tell me and I will solve it in another video. And now I will see you all in the next class. Thank you.